Bearcats, we are going to talk tonight about transforming quadratic functions. They're U-shapes and we're going to shift them up, we're going to shift them down, we're going to make them skinny, and we're going to make them fat. And remember, we can call them that because they are parabolas, not people. All right, so let's get started on our little adventure here. We need to first be able to say what the axis of symmetry, vertex, and whether the function opens up or down. On number one, it is going to open up because the 2 is bigger than 1. The axis of symmetry, since the b is 0, my axis of symmetry is going to be x equals 0. And my vertex is going to be 0, 0, because when I plug in 0 here, in return, I get a 0 back. On number 2, it is going to open down. Oh, I forgot to say number 1 opens up. It's going to open down. The vertex is going to be negative b over 2a, but it doesn't have a b, so that gives me a 0. Then when I plug in 0, I get 0 squared, which is 0, and 0 times negative 5, which is another 0, and the vertex ends up being 0, negative 4. The axis of symmetry would be x equals 0. All right, the next thing we have to do is a little bit more difficult questions. Find the axis of symmetry, the vertex, and the y-intercept. The axis of symmetry is the x equals negative b over 2a. 4 is b, so negative b would be negative 4 divided by 2 times 1, which is negative 4 over 2, or negative 2. Then I have to take that negative 2 and plug it in. And I get 4 minus 8 plus 5, which is negative 4 plus 5, which is 1. So my axis of symmetry is x equal negative 2. My vertex is negative 2, 1. And the y-intercept is the number on the end, which is 5. So those are all my answers for that problem. Number 4, we kind of just covered this one a minute ago, but let's do it again. My axis of symmetry is negative b over 2a. b is 0, so that means x is going to equal 0. Then when I plug 0 back in, I get 3 times 0 squared plus 2, which is 2. So my axis of symmetry is x equals 0. My vertex is 0, 2, and the y-intercept is also 2. Number 5, negative b over 2a will be negative 2 over 2 times 2, which is negative 2 over 4, or negative 1/2. Now I have to take that and plug it in. 2 times negative 1/2 squared plus 2 times negative 1/2 minus 8. Well, negative 1/2 squared is 4, so that's 2 times 1/4. 2 times a half cancel, and I'm left with negative 1, and then minus 8. Well, 2/4 here is 1/2. So I now have 1/2 minus 1 minus 8. So that's negative 9 plus a half, which is negative 8.5. You can leave this in fractions or decimals. I believe my answer here is going to be in a fraction, but you would also be right if you said negative 0.5 and negative 8.5. All right, good job. Now that we're all warmed up, let's get busy. We are now going to graph and transform quadratic functions. Remember that y equal x is the linear parent function. Well, the quadratic parent function is y equals x squared. Okay, there we go. There it is. And we're going to shift it up and down and left and right. So for the parent function, the axis of symmetry is x equals 0, or the y-axis. The vertex is 0, 0, and the function only has one 0 because it only crosses the axis one time. Okay, so if we look at these, whenever you put a coefficient in front of the x squared, it does certain things to the function. If you notice, all of these have the same b and the same c, but they all have a different a. The A affects whether it opens up or down. It also tells you if it's going to be skinny or fat, or we could call it narrow, more narrow, and things like that. Okay, so let's look at this real quick. If you compare the graphs, this one is x squared right here, and it is more narrow than 1/2 x squared, which is the outside one. Then if you look at it, negative 3x squared is actually the most narrow, but it's going down. So actually the negative is not what affects if it's skinny or not. So what's different is the value of A is going to make a difference in the width of the parabolas. All right, let's look at these. We need to order these two from the narrowest to the widest. If it has a number in front that is larger than 1, it is going to make the quadratic function skinnier or more narrow. And 1/2 x squared is going to make it a little bit thicker. So first thing we're going to do, it says to find the absolute value of the number because the negative would not really matter as far as the width is concerned. Now, since 3 is larger than 0.05, what's going to happen is the 3 is going to be more narrow and the 0.5 is going to be less narrow. Since it says from narrowest to widest, 3x squared is the narrowest and 0.5 is the greatest. And this has a mistake right here. All right, example 6 continued. To order these, we would just put them in order. Now you could look at a calculator to check these. And if you look right here, you can see, take a guess at which one this is. You are right. This is going to be 0.5x squared, and the more narrow one is 3x squared. Oh, there they are labeled. All right, let's try one more and see how this goes. Remember, the negative is not going to make a difference with the narrowness of the graph of the parabola. So we need to start with the largest number. So h of x is going to be the most narrow with negative 2x squared. Now we know that the negative means it goes down, but that doesn't affect anything as far as the narrowest is concerned. Narrowness. All right. The x squared is our norm parabola, and he is the one in the middle. He is x squared or 1x squared. So my f of x equal x squared is the second most narrow. And the fattest of them all is g of x, which is equal to 1/2 x squared. The 1/2 actually makes the graph more wide. Then to check this in the calculator, you can see the different steps of these graphs. 1x squared is the graph that's in the center. Negative 2x squared is going down, but it's actually the most narrow. And 1/2 x squared is the widest graph. Okay, now we're going to add, we're not going to change the coefficients in front. We are going to change this number on the end. Do you remember what that number is called? That is the C value. So this is A, this is B, and this is C. And if we change the C, we're actually changing the y-intercept. Now, by changing the y-intercept, we are changing the vertex of the parabola. Now, it looks like the width of all these, it looks like the width is getting smaller and bigger, but it's actually not. It's just because the parabola is shifting up and down. The value of C makes them look different, but it is actually, here, I want you to write this word down. It is a vertical translation of the graph, shifting it up or down on the y-axis. All right, so if C is greater than 0, then it's translated up. If C is less than 0, then the graph is translated down. So let's compare the parent function, which is x squared, with the negative 1/4 x squared plus 3. The first thing that's going to happen, we can look at the graph to see. 1x squared is going to open up, and negative 1/4 is going to open down. Now, negative 1/4 is going to be more wide than 1x squared. Okay, so the graph is wider, and then you can also say that negative 1/4 x squared opens down and x squared opens up. So you really need to comment every time, comment on 2 things every single time. 2 comments. The things that you should comment on is always talk about the width of the parabola. And the second thing is to compare the y-intercepts or the vertex. Okay, if you look at the graph, you can see the axis of symmetry is the same for both of them. The vertex of x squared is 0, 0. The vertex of g of x is 0, 3. And the final thing you would need to say is that the vertex for the g of x is shifted up 3, and it's also going down. All right, I went over this in class today, but this is the formula used to approximate height in feet above the ground of a falling object. It's dropped. Now, we're not talking about kicking a soccer ball, but actually a dropped. It's a falling object, and it does not take into consideration air, wind, or other real-world factors. Okay, so we have 2 formulas to write. We have 2 identical softballs. The first is dropped from a height of 400. So I'm going to do y is equal to, or f of x is equal to, negative 16x squared plus 400. My second graph, I'm going to call it y2, is going to be negative 16x squared plus 324 feet. Now, looking at these 2 graphs, I can tell you right now that this y-intercept is much higher, but the width of the graph is exactly the same. In fact, it is 76 meters from the first one to the second one. There's a difference of 76 meters in their starting height. Starting height. Okay, more fun. Whoops. Okay, we're going to use our graphing calculator. Since you don't have one, I'm going to put it on here. When I graph this, I need to be careful and only graph in the first quadrant because I can't have any negative time or distance when something is falling. So I bet you can guess which is which. The second one, which is right here at 324 falling, and the first one that dropped was starting at a height of 400. You can't have any negative values, and like we said just a minute ago, H2 was 76 units higher than the first one. So vertical translation, you remember that translation word, SL, stood for what? Slide. So the first one is dropped 76 feet higher than the second one. Use the graphs to tell when each touches the ground. The zeros are when it reaches the ground. Please write that down. The zeros is when it touches the ground. We went over a few of those today. Remember the juggler? All right. The softball that was dropped from 400 reaches the ground in 5 seconds. Now, if you look in your table, I know you don't have a calculator, but if you look in your table, 1, 2, 3, 4, right at 5, well, it's going to start off at 400. But at 5, it's going to give you a 0. That means it's hit the ground. Okay, now the second one, 324, is going to reach the ground in 4.5 seconds. All right, we are going to be working on this quiz tomorrow, so I hope you've had a great time learning about transformers in math. Yes, I did say transformers. Isn't that a great movie? All right, talk to y'all later, and I will be here at 7 a.m. for any help that you may need. Bye.